Good morning, Algebra 2. Today we are doing Lesson 33, Applying Counting Principles. And I am going to read through these examples with you. There's quite a bit of reading here. I think you'll find it straightforward. Please text me if you have any questions. My number again is 303-475-4493. Tell me your name, what lesson number, and what number of homework problem you have a question on, and I will send the solution back to you. In addition, when you're done with your completed lesson, please send me a clear photo of your homework to my school email and include your name and the lesson number in the subject line. Make sure that I can read the lesson and make sure that you show your work in order to get credit. Okie dokie, so lesson 33 is going to be applying counting principles. And if we consider the first example, where a cafeteria offers a turkey, ham, and chicken salad sandwich. The bread choices are rye and wheat. How many different sandwiches can be ordered? First, we need to consider the outcomes. I can have a turkey on rye or wheat. I can have a ham on rye or wheat. I can have a chicken salad on rye or wheat. So there's a total of 6 different sandwiches that can be made. Okay, that is going to be considered our outcome or our sample space. If we consider the counting principle. Let me get my camera ready here. Okay, again, we want to find the outcomes in these two scenarios. So look at A. What are the number of outcomes if I want to draw an ace or a face card by drawing a card at random from a standard deck? Well, the events draw an ace and a face card are mutually exclusive because aces are not face cards, okay? We're going to just count the outcomes. We know there are 4 aces in a deck. There are 4 jacks, 4 kings, and 4 kings. So there are 12 face cards. I think I said king, king, queen, king. So a total of 16 outcomes. Eventually we're going to find the probability of drawing either an ace or face card. So first we're practicing, how do I figure out the outcomes? How about for scenario B? There are, let's see, move that around here. Okay, we again want to figure out the outcome of choosing a prime number or a multiple of 6 or a multiple of 10 by choosing a number at random from the whole numbers 1 through 20. That's our sample space. So the number of outcomes, a prime number, well, there are 8 prime numbers, 2, 3, 5, 7, 11, 13, 17, and 19. Remember, 1 is not a prime number. Then there are 3 multiples of 6, 6, 12, and 18. There are 2 multiples of 10, 10, and 20. So a total number of outcomes, if we add those together, 8 prime numbers, 3 multiples of 6, and 2 multiples of 10, we will get 13 possible outcomes. Okie dokie, the fundamental counting principle, notice we did the addition counting principle, now we're going to do the fundamental counting principle, is where we're going to use multiplication instead of addition. Up here, we added to find our total number of outcomes. Now we're going to multiply to see our total number of outcomes, and you will see why. A student is choosing a 3-letter password to use for an email. How many passwords are possible if letters may be repeated? Well, consider that we have 3 spaces representing our password. Okay, let's say we have 3 spots representing our password. We have the first position, the second position, the third position. I could put all 26 letters. I could put A, I could put A, BA, I could put ACA, and you could see why we're going to end up multiplying. So I would consider that there are 26 choices because there's 26 letters in the alphabet for the first position. Then I can repeat, so I can use all 26 for the second. I can use all 26 for the third. You can see that if you chose all the different possible arrangements for this password, we would have a lot. In fact, we would multiply those choices because A times every letters in the alphabet would give us the first group of choices. But if we multiply them, we have 17,576 possible passwords. Okay, well, let's consider another example. Give me a moment while I get the book ready. Here we go. Okay. If I consider that same idea, how many passwords are possible if the letters may not be repeated? Well, consider your 3 spaces again. You have the first letter, the second letter, the third letter. I have 26 letters to choose from for the first position. Once I pick one of the letters, I can't use it again. So now I only have 25 letters to choose from. Now that I've used 2 letters, I only have 24 letters to choose from. Again, if I multiply those, we see there's still quite a few choices, 15,600 possible outcomes for those passwords. Again, from review from Algebra 1 and Geometry, 2 events are independent if the probability of one event is not affected by whether or not the other event occurs. 2 events are dependent if the probability of one event is affected by whether or not the other event occurs. This is going to happen when we're drawing something and we replace or we don't replace. So let's look at this next example. The letters A through E are written on 5 index cards. A card is chosen at random, and then another card is chosen at random. Determine whether the events in each case are independent or dependent. Well, if I choose A and then B and I replace before the second card is chosen, do you see I have the same possible chances, same probability of getting B because I replaced. So that's going to be independent. But if I choose A and then B, but I keep the first card, I do not replace it. Now the probability for B has actually gone up because there's less in the pot to choose from. So these events are going to be dependent. Let's consider example number 5. This one will be dependent. For volleyball players, this will make sense. There are 6 positions in volleyball. Left front, center front, right front, left back, center back, right back. How many ways can 6 players be placed in the 6 positions? Well, consider the combination idea, fundamental counting principle. We know that we cannot repeat players. A left front player cannot also be playing in the right back position. So for the first position, I have 6 players to choose from. Once I place a player, I now have 5 players to choose from. Once I've placed 2 players, I have 4. Once I've placed 3 players, I have 3 left to choose from. Now I've used up 4 players, I have 2 left to choose from. I've placed 5 people, I have 1 person left to choose from. Multiplying that, the fundamental counting principle, we realize there are 720 ways to place 6 players into those 6 positions. All right, fundamental counting principle, we're going to multiply. The addition principle is where we simply add up the number of outcomes. Alrighty, this assignment will be due on Tuesday by your class period time. Please text me or email me, or actually text me if you have any questions. Thank you very much.